Welcome to a lesson on rates of change in general science. So I'm going to show you just a quick overview. There's many uses for calculus in the general sciences, but I got a couple of examples to go through and show you today. So what's the goal? You can apply prior knowledge, so that means taking derivatives from this course, and I want you to be able to take it into your chemistry lab or chemistry courses next year, your biology courses, your physics courses, and so on and so forth. So understanding the notation, I'm just going to revisit what we talked about way back in the start of Unit 3, and it's the Leibniz notation, so the dy by dx. All right, and we're going to be looking at it in a couple different forms over the next couple of days. But remember, this is change in y with respect to the change in x. All right, so if we want to talk about pressure and volume, the change in pressure with respect to volume. So change in pressure with respect to volume. So we're talking about a change in rate. All right, and I'm going to start using Leibniz notation more and more into Unit 4 because it's sort of becoming more and more applicable. So first example I have here, wheat yield. So this is for the Aggies, the ones that are going to Guelph. Wheat yield depends on the amount of seed, S, planted. So S is how much seed is being planted. It's a mass. The yield is in kilograms, and it's defined by capital Y. So that's the yield based on how much is applied. So the range, or sorry, the possible domain, or sorry, no, it's domain. A farmer is going to put on between 50 and 200 kilograms per kilogram. That's the amount that they can actually plant with. So we want to find, in the question itself, it wants to find the rate of change in yield for 100 kilograms. So again, keying in like you did last semester in the 4U course, the MHF, it's that rate of change. That's what tips you off that you're looking at taking a derivative here. So we know for answer to A that yield is defined by the equation up above. And if I want to know how the rate of change of the yield, I'm going to take the derivative of the yield. Now I did say I'm going to use Leibniz notation, so what would that look like? We're looking at the change in rate of yield, so dy with respect to the amount of seed applied, so dy by dx. And that looks like a 2. I can do a little bit better than that. All right, so taking the derivative, we end up with negative 3 over 20, so it'd be 6 over 40, which reduces to 3 over 20s plus 30s. And the question's asking us to evaluate at 100 kilograms. So if we let S equal 100 kilograms, then our rate and change in yield with respect to S is the negative 3 over 20 multiplied by 100 plus 30. Whoops, when I took that derivative above, there should be no S there. My mistake. So fixing that up, 3/20ths of 100, you're looking at negative 15 plus 30. So it's 15. Now let's talk about the yield here, okay? Or sorry, let's talk about the units. The units are very important. So yield is measured from the question in kilograms. So it's in kilograms. And the amount of seed that we're putting on is in kilograms. Now, although it's the same unit of measure, it's not measuring the same thing. So we need to put it as kilograms per kilogram. So therefore, the yield is increasing at 15 kilograms per kilogram of seed. Okay, those kilograms are measuring different quantities. So the rate of yield as you put on 100 kilograms of seed onto a field, the yield is increasing at 15 kilograms for every kilogram that you're adding. B part then. Determine the amount of seed to optimize yield. Okay, so we're looking at determining how much do we want to optimize or maximize our yield. So maximize, looking for a max min, which means that we are going to have to set the derivative equal to 0 in order to locate the max value. So 0 will equal the negative 320s plus 30. So negative 30 equals negative 320ths. Negative 10 equals negative 120ths. So I'm just doing this in a couple of steps. So we end up with 200 equals s. So our units here are in kilograms. So put that in there. So therefore, for this particular product, you will need to put on 200 kilograms of seed to maximize profit, to maximize yield. So to maximize yield, we must use 200 kilograms of seed. Okay, and that's usually referenced, for those that aren't from the farm, that's referencing how much is used per acre or per hectare of land. Okay, so there are some of the questions that if you end up working for Pioneer or Pride or one of the ag companies, this is something that you do look into. You look at optimizing and maximizing yield and returns for farmers. Okay, on to the next example. Biology example, the number of bacteria, N, in a culture after T hours is approximated by that equation. What is the rate of the change in population after 2 hours? So we are looking at N of T equals 10 to the 5th, 1 plus the 2T squared. So very carefully, we're going to take this derivative. We're noting, okay, out front, this is just a coefficient, it's just a number. Our actual variable is right there. So I'm going to take the rate in change in bacteria with respect to time is equal to 10 to the 5th, and I'm going to take the derivative of what's inside the brackets there. We would have 0 plus 4t, which would simplify to 10 to the 5th multiplied by 4t. And that units, and this is important for these word problems, bacteria per hour. So units are something I'm going to be looking for in terms of your communication. So please make sure you're diligent in putting those units in. So T equals 2 hours. So that would mean that our population is changing at 10 to the 5th multiplied by 8 bacteria per hour. So that means that at that point in time, at 2 hours, this is how many bacteria are being produced at that point in time. Okay, so at that exact moment. So at 2 hours, the rate of growth is 10 to the 5th times 8 bacteria per hour. All right. So keep in mind, this question itself was a parabolic question. So it's a curve. So when you're taking the tangent of the curve. So that's continually changing. So that rate of growth will change as time goes on. So from chemistry, so for all the budding chemists out there, we know that Boyle's law says PV equals K. I want to show that the rate of change in pressure with respect to volume is negative PV. So it's a proof. So Boyle's law says pressure times volume is constant. So we're going to take the derivative with respect. So we're really going to take the derivative with respect to volume. All right. What does that mean? It means we need to be aware that we have two variables multiplying each other, which means we're going to have to use our product rule for derivatives. Product rule for derivatives. So we're going to take the derivative of pressure with respect to volume multiplied by volume plus pressure multiplied by the derivative of volume with respect to volume equals, and remember K is a constant for those that haven't taken chemistry, derivative of constant is 0. Now dV by dV, this means we're comparing the rate of change in volume with respect to volume. That's a 1-to-1 ratio. So that value itself is a value of 1, which means we have the change in pressure with respect to volume is V plus P equals 0. We are looking for the change in pressure with respect to volume, so we're just going to isolate dP by dV. That's going to be negative P. So the change in pressure with respect to volume is equal to negative P over V. So therefore, as shown. All right. So it's just using something from chemistry, and we're showing that the change in pressure with respect to volume is equal to negative P over V, a formula I'm sure you're given when you're going through the 3U and 4U chemistries. All right. Last example. So now we're looking at another chemistry example here. So in the first order reaction, the equation that governs the amount of reactant is that A naught is the original concentration, so it's a constant. A of T is the concentration at any time, and K is the reaction constant. So I think for just time purposes, rather than rushing and jamming this in, I'll do this in the next video, this final example, which will only take a couple minutes.